My name is Maxim Velichkin. I'm an augmented reality and virtual reality developer and 3D graphics artist at Armature. And today I'll be happy to show you the augmented reality project which we developed for the Nike shoes for Microsoft Hololens and Google Tango. And in particular, I will be happy to focus on the process of 3D assets creation and 3D graphics for augmented reality. 3D graphics, augmented reality becomes more and more common part of our life. It can be a really handy tool in many cases, like in healthcare, in education, and also in shopping. And we're able to shape the experience of augmented reality which we have with the help of 3D graphics. We have almost unlimited possibilities of creation in 3D.
Can you a little bit louder that people are starting to
Okay. Okay, shall I start again?
Can you just speak louder?
Yes. Yeah, definitely. Okay. Okay. Hello everybody. My name is Maxim Velichkin. I'm an augmented reality and virtual reality developer at Armature. And today I'll be happy to talk about the augmented reality project for the Nike shoes, which we developed for Microsoft Hololens and Google Tango. So augmented reality becomes more and more common part of our life. It can be a handy tool and a helper in our life in many cases and many situations, such as in healthcare, in education, and also in shopping. And we're able to shape the overall experience in augmented reality with the help of 3D graphics. We have almost complete freedom of creation. We can visualize basically everything which we can imagine. But we still have some hardware and software limitations, which is restricting us. So I will going to speak about some techniques which helps us to overcome these limitations. But before we'll start to speak about the challenges of 3D graphics, let's have some quick overview of what 3D graphics is and how basically 3D models appear. So 3D models are made of polygons. Polygon is a core concept in three-dimensional graphics. Polygons, you can think about polygon as about a very simple geometric shape. The simplest polygon is made out of points, called vertices, connected with straight lines, called edges. At least 3 vertices connected with edges form a triangle polygon, the simplest polygon possible. We can shape the surface of three-dimensional objects out of filled polygons. So it looks something like this. So we have a vertex. Now we have 2 vertices connected with the edge. And if we will connect 3 vertices together, we will receive a simple polygon. The common case for modeling is a polygon made out of 4 vertices. And out of this polygon, we can start modeling. So we can extrude this polygon, and we will be able to see the simple geometric shape of the cube. We can continue extruding polygons, and thus this is basically already a process of 3D modeling creation. But this is some very simple demonstration. A little bit more complex and a little bit more meaningful example would look something like this. So this is a time lapse. So this is a process which, with increased speed of the modeling process, we are extruding, subdividing, moving polygons, vertices, and edges to make some shape. And we can smooth the shape using different modifiers. We can combine different meshes together. We can add some basic color. So basically, we just create some model out of simple polygon from scratch. And we can go wild. We can keep adding some more and more stuff here. But basically, we should remember that everything here starts with only one simple object, with the polygon or with a simple geometric primitive. So the same way we created these Nike shoe models. What you can see is called Wireframe. This is basically kind of an X-ray of the model which demonstrates the structure, the polygonal structure of the model. On these pictures you can see pre-visualized or rendered images of the Nike shoes as well as the shoes models in the wireframe mode when you can see the polygonal structure. As you can see, the density of the polygons is different on different areas of the shoes. At the modeling stage, we don't need textures or anything that will grab our attention out of the modeling process, so the shoes looks gray on this stage. Later on, there will be added more textures and colors, of course. So if you will see on this sole of the shoe, for example, you'll be able to see that there, where we have this smooth shape and fine details, we have more dense polygonal regions than in the other areas. We'll come back to the sole later. So during the texturing process, we have to create something called UV map. This is basically a two-dimensional representation of a three-dimensional object. So you can think about it as like about the process of creating the two-dimensional map out of the globe. You have a spherical globe, and you're marking some seams, you're making some cuts, and finally you're creating the two-dimensional representation of this globe as a map. And we have to try to avoid as much distortions as possible. One of the most interesting challenge here was to create the model which can be expanded into several individual elements. So we wanted to be able to demonstrate what is it made of. But at the same time, we wanted to create the shoe which can walk and run. And these two goals was kind of a mutual and exclusive, because if you, as you can see here, we use an armature. This is basically a set of joints, and when we attach our model to the set of joints, we create in so-called weight maps. So each joint have this some areas of the model and influence the model with different strength. And thus, when we move in the joints, we deform the model. But when we actually want to expand the model into individual elements, we want the model to be detached from the armature. So in order to achieve this result, we combine different animation techniques like Shapekey animation, keyframe animation, Armature animation, and we end up with the Shapekey animation. So what is a Shapekey? Basically, a Shapekey is a way to keep the information about position of each vertex of the model in space in one moment of the time. So it's like a phase in two-dimensional animation, and we can iterate from one phase to another phase. So what you can see here is the keyframes and the Shapekeys and some cursor. The Nike shoes is a pretty elegant object for recreation, but beside the overall geometry, it has these perfect imperfections. It has some patterns of material, it has some texture, and it's something that can be actually represented naturally with manual modeling. So that's why we use a technique called sculpting. During the sculpting process, we use sculpting brushes. Sculpting brushes is basically a simple black and white images, where white areas forces vertices to go up, and dark areas are forcing vertices to go down or remain in the same place. And here how the sculpting process looks like. So we're setting up the sculpting brush, and we're starting sculpting. At the moment, we're currently deforming the vertices and polygons on the surface of our model. And as you can see in one move, we just created the complex structure. And as you can understand, for the sculpting brushes, we can use any realistic real-life images. So it's a way how we can recreate these natural, not handmade patterns on the surface of our model, like skin, like material, surface, etc. So this way, using sculpting techniques, we can take something like this and turn it into something like this. And here we come to the second challenge, because we actually can't use this model. Because when I speak about deforming the shape of the model, I speak about moving vertices and polygons. If we want to create a lot of small details on the surface of a model, we need a lot of polygons. And this particular model, with a lot of fine detail, might have approximately 10 million polygons, for example, which is too much for augmented realities by far. So the technique which helps us to overcome this limitation is called normal map. Let's start with a simple example. Assuming we have a simple sphere. It's a pretty low polygonal object. If we'll go to the wireframe mode, you will be able to see that it have not so much polygons, approximately 512. Now we subdividing the polygons, creating smooth sphere with a lot of polygons, we're adding some sculpting. So let's look at the wireframe mode. As you can see, the density of the polygons is so high that we can't even see the polygons at all. It looks like it's filled with the color because of the density of the edges. So if we come closer, and a bit closer, and a bit closer once again. Only now we can distinguish some small polygons shaping the surface. So the question is, how can we transfer the information about the geometry of the model, which have approximately 8 million polygons, to the model which have like 500 polygons? And the answer is normal map. But in order to understand what is normal map, we should understand what is normals. Normal is basically a vector which is perpendicular to the surface of the polygon. So the direction where normal is pointing at is actually the direction when the polygon is facing it. So here's our low polygonal model. No. I don't see the mouse cursor here. Yes. So here's our low polygonal model. And here are the normals of the polygons of the polygonal model. So the normal map allows us to keep information about the direction of each normal on the surface of the model, of the object, in the form of two-dimensional image. This is a normal map. This is basically just a simple flat image. But the shades between green, red, and blue colors here keeps the information about the direction of the polygon on the surface of the model. And then higher resolution of the normal map, the more information we store. So if we'll apply this normal map to a low polygonal sphere, we not actually change its color. We change the way light behaves when it's touching the surface of the model. So it's hard to move when we don't have a cursor. Yeah. So here you can see our model, and when we move in the light source, we see the real-time update of the light and shadow on the surface of the model. So this is a complete emulation of the geometry, which produces almost no load on our devices. And this way we can transfer information about all this geometry to the low polygonal objects. So basically this way, as you can see, we can see our model before normal maps and after normal maps. So normal maps helps us to create a lot of keep and transfer from high polygonal versions a lot of small details, create a realistic result for the low polygonal versions, which is acceptable for augmented reality. We can use normal maps in order to transfer information from the sculpting as well as from the modeling. If you remember this soul, which I was talking about a bit before, we can completely replace it with normal map. As well as many other parts of the shoes. We use it for shoelaces and sole and so on and so forth. And here is the final demo of the application. So this is what you can see is video recorded from the Hololens. We are launching the application. We're developing it with Unity. And now you see the Nike shoe, which is snapping to the surface of the table. So it's not snapping to some virtual environment. It's actually analyzing the real world environment around us and can understand that this is a flat surface for the table. So we can place the shoe here, and we can use UI elements as well as voice commands. I'm not sure if you have sound, but currently I will be using yes, we don't have it, but currently I'm using the voice commands to manipulate the model. So I can say expand, walk, or run, and the model will be animated. And also this model will be attached to this place in the real world environment. So we have no need in manually placing it, or we don't need to stay in the same place. We can walk around, it will remain here. We can also change the model of the shoe, and we can change the color, and we can use voice commands or gestures or visual UI elements for manipulating the model. So you can see we can select different model and also use voice commands. So basically, we saw some case stages of the process of 3D assets creation. We saw some techniques which helps us to overcome the hardware software limitation during this process, but there also will be challenges during the complex tasks, during the interesting tasks. And we just have to keep experimenting, because there also will be some solutions, and there are very few things impossible in our reality. Thank you.